Now, with the derivative of ln x, and the derivative of ln x is 1 over the function at the front of the ln multiply derivative of the function, multiply by derivative of the function. So it's reciprocal of the function, multiply its derivative. For example, if y is equal ln 7x, find dy by dx. So if y is equal ln 7x and I wanted to find dy by dx, so dy by dx, derivative of the left hand side, is the function is 7x, so it's 1 over 7x, multiply by derivative of 7x, and derivative of 7x is 7. This one can be simplified by cancel 7, so it's 1 over x. Again, example 2, if y is equal to ln of 3x squared, find dy by dx. So dy by dx is equal 1 over the function, which is 3x squared, multiply derivative of the function itself, which is 6x. This one can be written as 6x over 3x squared. 6 divided 3 is 2, by cancel 1 of the power of x, so it's 2 over x. 2 divided by x, or 2 over x. Y is equal ln x to the power of 3, and I wanted to differentiate this function with respect to x. So the left hand side is the derivative of y with respect to x, and derivative of ln, as we can see the rule here, it's 1 divided by the function multiply derivative of the function. So the function here is x to the power of 3, so 1 divided by x to the power of 3, multiply the derivative of x to the power of 3, and the derivative of x to the power of 3 is 3x squared. So 3 multiplied by 1 is 3, and x squared divided by x to the power of 3. Now I can simplify the numerator with the denominator, so I can cancel x to the power 2 with x to the power 3, so the remainder will be up 3 and down x. So the derivative of ln x to the power 3 is 3 over x. Differentiate each or the given function with respect to x. Y is equal ln of 2x to the power 4. So we are going to assume that this is u. And from the rule here, we know that the derivative of ln u is 1 divided by the function multiplied derivative of the function. So dy by dx is equal 1 divided by u, and u is ln 2x to the power 4, multiply by derivative of ln 2x to the power 4, and derivative of ln 2x to the power 4 is 1 over the function multiplied by derivative of the function, and derivative of 2x to the power 4 is 8x to the power of 3. Again, here you have two functions. The first one is ln 2x to the power 4, and this is represent u, and the second one is 2x to the power 4 itself. Now let's simplify it. So it's going to be 1 over ln 2x to the power 4 multiplied by 8 divided by 2 is 4, and x to the power 3 divided x to the power 4 is x. So it's 4 over x multiplied by 1 over ln 2x to the power of 4. This is all represent the derivative of the function y with respect to x. Differentiate each of the following with respect to x. The function is y is equal ln of ln 3x above 3. Don't forget that we have a rule that if u is a differentiable function, so derivative with respect to x for ln u is equal to 1 over the function multiplied derivative of the function. So we are going to assume that this one is u. So we are going to assume that u is equal ln 3x above 3. So what is du by dx? What is the derivative of u with respect to x? It's 1 over the function itself multiply derivative of the function. Derivative of the function is 9x squared. Let's simplify it. So du by dx is equal 9 divided by 3 is 3, and x squared divided x power 3 give me x to the power of 1 in the denominator. So it's a 3 over x. 3 over x. Now let's go back to the function. So dy by dx is equal 1 over the function, which is ln 3x above 3, multiply derivative of the function 3 over x du by dx. So it can be written as 3x multiplied by ln 3x to the power of 3. Differentiate the given function with respect to x. Y is equal cosine ln to 4x to the power of 3. Notice that the old teachers telling you that if u is differentiable, so the derivative of ln u is equal 1 over u multiply the derivative of u. So ln, the derivative of ln a function is equal 1 over the function multiply derivative of the function itself. So we are going to assume that this function is cosine u. So u is equal ln 4x to the power of 3. So du by dx is equal 1 divided by the function multiply by derivative of the function, which is 12x to the power of 2. 3 multiplied by 4 is 12. Subtract from the exponent 1, it's x power 2. So du by dx is equal 12 divided by 4 is 3. And x squared divided by x power 3 is x. So it's a 3 over x. Now, the derivative of dy by dx for cosine u is negative sine u du by dx. So it's negative sine, and u is ln 4x power 3. All of this is multiplied by the derivative of u, which is 3 over x. So this one can be written as negative 3 over x sine ln of 4x to the power of 3. Question number 5. Differentiate each of the following with respect to x. Y is equal ln of 4x squared multiply negative x to the power of 3 minus 4. So we can see that it's a product rule, and the derivative of the product rule is equal to derivative of the first multiply the second plus derivative of the second multiply the first. So dy by dx for the given question. Derivative of the first is going to be 1 over the function multiply derivative of the function 8x, and this is the derivative of the first multiply by the second negative x to the power of 3 minus 4 plus derivative of the second negative 3x squared. Derivative of negative x to the power 3 is negative 3x squared multiply the first ln 4x squared. Let's simplify it. By dividing by 4 give me 2, and by cancel one of the x with the power, so it's 2 over x multiply by negative x to the power 3 minus 4 plus negative 3x squared multiply by ln 4x squared. So 2 over x multiply negative x to the power 3 is negative 2x squared, and 2 over x multiplied by negative 4 is negative 8 over x, plus I can write it as a negative. By multiplying positive by negative is negative, and I can erase the bracket. So it's negative 3x squared ln 4x squared. So this is dy by dx. Differentiate the function with respect to x, and the function is y is equal ln negative 4x to the power 4 over x to the power 3 minus 3 to the power 5. As we know that from the properties of logarithm, that ln of x to the power of n is the same as n ln of x. So I can write this y as 5 ln of negative 4x to the power 4 over x to the power 3 minus 3. Something else. I have a rule which says that ln a over b is equal ln a minus ln b. So it's equal 5 multiplied by ln negative 4x to the power 4 minus ln x power 3 minus 3. This is y. So I can say that y is equal 5 ln of negative 4x to the power 4 minus 5 ln x power 3 minus 3. Now let's use the rule of differentiation for the logarithm, that d by du d by dx for ln u is equal 1 over derivative of u du by dx. So it's 5. I put down the function negative 4x to the power 4 multiply derivative of the function, so it's going to be negative 16x to the power 3 minus 5. I put down the function multiply derivative of the function 3x squared. So I can simplify it by cancelling or dividing by negative 4. So it's going to be negative 4 here. It's going to be 4 by 5 is 20, so 20 over x after cancelling x to the power 3 with x to the power 4 minus 5 times 3 is 15 and x squared over x power 3 minus 3. And this one can be simplified more by multiplying the same denominator. So it's x multiply x power 3 minus 3, and 20 times x power 3 is 20x power 3 minus 60 minus 15 times x is 15x power 3. So it's x multiplied by x power 3 minus 3, and 20 minus 15 is 5, so it's 5x power 3 minus 60. If we're going to take 5 as a highest common factor, it's going to be x power 3 minus 12, which is not b, so this is the simplest form.